One more example of being able to use the trigonometric functions of the sines of the trigonometric functions. We have this cosecant is equal to -2, and the cotangent is greater than 0. All right, so we have our all students take calculus. All right, so right away, if the cotangent of theta is greater than 0, that means that the cotangent or the tangent must be greater than 0 as well. All right, obviously the cotangent is greater than 0, but also that the tangent of theta is also greater than 0. So it could be this quadrant, right? Um, it can't be this quadrant because the cosecant is -2. It can't be this quadrant because that means that the because the sine function is greater than 0, that means that the cosecant function must also be greater than 0 in this quadrant. And then down here, well, we know that the tangent function would be less than 0, and inherently the cotangent function would be less than 0 as well. And so it can't be this quadrant. So it has to be in quadrant 3 where this is living. Okay. Now remember, the cosecant is the same thing. So the cosecant of theta, by definition, is going to be r over y. Okay, and the way I remember that is because the sine function is y over r, right? And that means that we could write this as 2 over 1, right? So what this means, okay, if I'm doing this, is that the y value has to be -1 and r has to be 2, because remember, 2 is greater than 0. And so the only ways that we can write -2 is if it's -2 over 1, it would have to be -2 over 1, or it would have to be 2 over -1. And remember, r has to be positive. All right, so r has to be +2 and y has to be -1. Right? Now that also means that we need to figure out what x is going to be. Okay, so to figure out x, we have our relationship x squared plus y squared equals r squared. And in this case, we know that x is unknown. We know that y is -1, and we know that r is 2. Right? And so if we find this, we get x squared plus 1 equals 4, x squared equals 3. And that means that x is either going to be plus or minus √3. Right? Now, we know that we're in quadrant 3. Okay, so what we might want to do is just say that this is valid in quadrant 3. And we know in quadrant 3 that the x is less than 0 and the y is less than 0. Right. So that means that we have to pick the negative version of this. Okay. So x is going to be -√3. Right. And from before, we said that y is -1. And we know that r is 2. Okay. So now we can go ahead and try to figure out what our 6 trigonometric functions are. Now remember, we had already that the cosecant was -2, and that means that we can find the sine function by taking the reciprocal, which is -1/2. Right? So those are the easy ones. We know that the cosine function is going to be x over r. Now we know that x is negative square root of 3, and we know that r is 2. All right, so the cos of theta is going to be -√3 over 2. That means that the secant of theta is going to be the reciprocal of that, okay, which would be -2 over √3. And then we should probably rationalize that by multiplying by √3 over √3. And so this would end up being 2 roots of 3 over 3, the negative of that. Okay, so this will be -2 roots of 3 divided by 3. Right? So we've got 4 of them so far. Just need the last one for tangent and cotangent. We know that the tangent of theta is going to be y over x. We know that y is -1. And we know that x is -√3. Okay, so that's the same thing as 1 over the square root of 3 positive. And then we're going to rationalize it by multiplying by √3 over √3. And so multiply by √3 over √3. And that should end up being √3 over 3. So that would be √3 divided by 3 when we simplify that expression. All right, sorry. All right. Now, the other thing we have to do is we have to find the cotangent function, but that should be pretty easy because all we have to do is just take the reciprocal of this, because remember the cotangent of theta is going to be x over y, right? And we know that x is negative root 3. We know that y is negative 1. And so that just turns into positive square root of 3. All right, so there's our 6 trig functions. All right, so again, making sure that we understand how to work with the signs, SIG and S, of these sorts of trigonometric functions. Again, it's sort of like a deduction. We're just going to narrow it down by figuring out which quadrants it can't be. And by process of elimination, we figure out which one it is. Another concept that we're going to get used to is going to be these reference angles. All right. Now, a reference angle is going to be, and I'm going to call this, whenever we have a reference angle, I'm going to refer to reference angles as theta prime. Okay. So a reference angle to theta is the positive acute angle formed with the terminal side of theta. Right. So basically, if I draw a theta, right, then theta prime would be this angle, but it's the positive version of this angle, all right? So basically, if theta terminates in quadrant 2, to find the reference angle, it'll be 180 minus theta. If it ends up in quadrant 3, that's going to be this angle, okay? So basically, it would be theta minus 180, right? And then finally, if it ends up in quadrant 4, it would be this remaining angle. So basically, what number do you have to add to be able to get to 360? Okay, so basically, the way I think about it is, if it terminates in quadrant 2, what do you add to get to 180? If it terminates in quadrant 3, what do you subtract to get to 180? And then finally, if it terminates in quadrant 4, then what do you have to add to get to 360? All right, that's going to be your theta prime. All right, now these are going to be common trig function angles. All right, and we need to memorize these. Okay, now I think I showed you this in one of the previous videos, but I think I showed you a lot of things. But one of the ways that we can kind of remember the angles is if we remember 0, 30, 45, 60, and 90. Those are the common angles. One thing that one of my teachers showed me was that if you just keep going, square root of 0, square root of 1, square root of 2, square root of 3, and then if you do square root of 4 over 2, so basically the denominator is always 2, and then you just keep going up 1, 0, 1, 2, 3, 4, and square root of 4 over 2 is 2 over 2, which is 1. That's a way that we can just remember these, okay? So you can make this chart really quickly, okay? So for instance, if you're on a test, you might just go 0, 30, 45, 60, 90, and then you might just do root 0 over 2, root 1 over 2, root 2 over 2, root 3 over 2, and root 4 over 2, okay? And that's going to be 1, this is going to be 0, and this is a half, all right? And this would tell you the sine of the angle, the sine theta function, all right? Now, another thing that you can do to help yourself to memorize this is that the cosine of theta is just going backwards, okay? So remember, it's a cofunction. So you just say 1, and then root 3 over 2, and then root 2 over 2, and then 1/2, and then 0, okay? So basically, whatever you did to go up, then you could just do to go down, all right? And then you probably can figure out the tangent because the tangent is just going to be sine over cosine, all right? So for instance, if I wanted to know the tan of theta at 0, that would just be 0 over 1, which is 0, okay? Or if I wanted to know the next one, that would be 1/2 over root 3 over 2, and those would cancel out, and then we could rationalize it, okay? So that's just one way that if you're on an examination, that you can remember all of these angles, okay, just by kind of using this table, or you could just brute force memorize it, okay? It might be a little bit easier just to do it the way that I just showed you, just because that way you don't have to memorize it. All right, so now the question is, what do reference angles and all these have in common? Well, if we know an angle, okay, then what we can do, if we know the trigonometric function of the reference angle, then if we have in theta, okay, we find the reference angle, then the difference between those two is at best a sine. Okay, so if we remember the quadrants, remember we had that all students take calculus. then we can use this in conjunction with this and a reference angle to figure out the values of any trig function. Okay, so reference angles are actually pretty useful to us. Now, before we do any of that, let's just find reference angles. So I have this 137, all right? So if I just draw 137 degrees, okay, kind of looks like this, okay? So this would be theta, which is 137 degrees. The reference angle, which I'm going to call theta prime, is going to be the remainder, okay? So it would be this, okay? And theta prime is going to be 180 minus 137, all right? And in this case, if we subtract those, that's going to work out to be 43 degrees. Okay, so that's the reference angle, right? It's really easy to find a reference angle, right? If it's something like this, 13 pi over 7, then what we might want to do is we might want to convert that into degrees, okay? Or we could just go ahead and graph 13 pi sevenths, okay? Now, if I was to go ahead and convert that into degrees, I might just go ahead and say, okay, well, I'm going to go into my calculator, I might subtract it. So let's do this first. Let's go ahead and convert it. So I'm going to have 180 over pi, all right? And the pi's would cancel out. And so in my calculator, what I would do is I would take 13 times 180, and then I would divide that by 7. All right, so we get 334 degrees. All right, now we're going to keep this exact, but we just do this so that way we know what quadrant we terminate in. Okay, so if I was to construct this, okay, so this would be 334 degrees about, okay, it's probably a little bit more than that. Let me erase that. All right, try again. All right, so this is theta 334 degrees, okay, about, okay? Or we just say theta is 13 pi sevenths. Now, for us to figure out the rest of this, okay, right here, well, we know that all of this should add up to 2 pi, okay? So the total of everything should be 2 pi. So what I'm going to do is I'm just going to take 13 pi sevenths and subtract that from 2 pi. And that'll tell me what my reference angle is. Okay, again, if it ends in quadrant 4, then all we do is we just take 360 minus theta. Okay, so I'm going to take 2 pi minus 13 pi over 7. Then what I'm going to do is I'm going to get a common denominator. All right, so that way I don't have to subtract the approximate value. So what that means is I would just go ahead and get a common denominator of 7. Okay, so think of this as 2 pi over 1. I'm going to multiply by 7 over 7. And so I get 14 pi sevenths minus 13 pi over 7. And so that means that our reference angle theta pi is going to be pi sevenths. All right, and we want to try to get an exact value, so we're not going to go through and get some sort of approximation. All right, another example, and the final example, we just have this negative 29 pi 13ths. So again, what we probably want to do is just go ahead, figure out what quadrant that terminates in. Okay, so let's just go ahead and in our calculator, and again, to set this up, we are just going to multiply this by 180 over pi. All right, the pi's would cancel out. We're going to do negative 29 times 180. So we're going to do negative 29 times 180 over 13. And that's negative 401. All right, so the way I think about this is, so we have negative 360. Okay, so that's negative 360 degrees. And remember, we're just trying to figure out the quadrant. Okay, we really don't care about the exact angle. Okay, so remember, we had from our calculator, this is about negative 401. So what that means is if I have negative 401 and I already took away 360 degrees, okay, what that means is that I have about negative 41 degrees left to go. All right, and so that's probably going to end up like right about there. Okay, so this angle would be theta is negative 29 over 13 pi, right? Now, What we might want to do is add 2 pi, okay, and then kind of figure out what the rest of the angle is going to be from there, okay? So what I'm going to do is I'm going to take negative 29 pi over 13, and I'm going to add 2 pi, okay, just to kind of figure out what the leftover of this is, okay? So if I add 2 pi, that means I'm going to have to multiply by 13 and 13 to get to a common denominator. And so this means that I get negative 29 pi over 13 plus 26 pi over 13. That's going to be negative 3 pi 13ths. Okay. Now, realistically, what that means is that I need to add another 3 pi 13ths, or in this case, negative 3 pi 13ths, to get to this negative 29 pi 13ths. And so this angle right here, which I'm going to call theta prime, is going to be that 3 pi 13ths, okay? Not negative, okay? But that's how much more we would need. And remember, it's the positive angle that we need to formulate with the axis, okay? So that's how we can figure out our reference angles. Just figure out what quadrant it terminates in. And then from there, what you just need to do is figure out what angle is formed by the x-axis from there, okay? All right, so hopefully that helps out with reference angles. In the next video, what we're going to do is we're going to figure out what we can use the reference angles for, and that'll be it for this section.